Hey everyone, welcome back to Math with Sammy. Today we are diving into one of the most important skills in algebra, factoring polynomials. If you've ever struggled with breaking down those tricky expressions, don't worry, I've got you covered. By the end of this video, you'll know exactly how to factor polynomials like a pro, using different methods that make the process easy and intuitive. And of course, I've got a challenge problem at the end. Stick around and test your skills. Ready? Let's get started. So the first thing we're going to start with is the greatest common factor. That's the first thing you learn in factoring. And the greatest common factor, when you're factoring, so if we do example 1, you look at the two numbers, the 9 and 27, you look for the biggest number that goes into both these numbers. So here, if you notice, 9 is the biggest number that goes into both of them because 9 goes into itself once and it goes into 27 3 times. So 9 is your greatest common factor. Also with the variables, you look at the x cubed and the x to the 4. Always the variable with the least exponent, that what comes out as the greatest common factor. And then you have y to the 5 and y squared. This is with the least exponent, so y squared is your greatest common factor. And now you open brackets. If you want to know what you're gonna write inside, you just take this first term here divided by your greatest common factor. 27 divided by 9 is 3. X cubed divided by x cubed cancels because it's 1. Y to the 5 divided by y squared, you get y cubed. Minus. Now 9 divided by 9 cancels, it's 1, so we don't have to write it. X to the 4 divided by x3 is x. And y squared divided by y squared is 1, so you don't have to write that. And that's your answer. The way I do it, I just go 15x to the 7 divided by 5, x cubed, 15 divided by 5 is 3, x to the 7 divided by x cubed is just x to the 4. Then we have our plus, then 25 divided by 5 is 5, x to the 5 divided by x cubed, you get x squared, and then minus 50 divided by 5 is 10, x cubed divided by x cubed, that's gone, that's 1, and that is how you do the greatest common factor. Now we'll explore the second thing about factoring. So here is factoring trinomials. That's the second thing we're gonna do. So when you're factoring trinomials in the form x squared plus 10x plus 21, what we need to do here, the first thing is you open two set of brackets. And at the start of each one, put an x. And then what you're doing, you're looking for two numbers that multiply to give you 21 and add to give you 10. So always what multiplies to the constant at the end and adds to the coefficient of the x. That's how you factor them. So if this wasn't written in this order or a descending order like that, then you have to rearrange it so you have it in this order. And then it's always what multiplies to give you 21 and adds to give you 10. And all of them. So here, for instance, what multiplies to give you 77 and adds to give you negative 18. So let's go back to this one. What multiplies to give you 21 and adds to give you 10. That's definitely 7 and 3 because 7 times 3 will give me 21 and 7 plus 3 will give me 10. So both of them are positive. So x plus 3, x plus 7, it doesn't matter if you write plus 7 here or plus 3 there. It doesn't matter, so you can switch this around. So this is how you factor trinomials. Now, if you take this and expand it, if you remember foiling, you foil it and collect like terms, you'll end up getting this back. So factoring is the opposite of expanding. How about here? So with the same thing, you open two set of brackets. You put an x in each. Now you're looking for two numbers that multiply to give me 77 and add to give me negative 18. This looks to me like it's going to be negative 11 times negative 7 because negative 11 times negative 7 will give me 77. And when you add those, they'll give you a negative 18. So it's minus 11 minus 7. Yeah, so we'll go to this one. This one here, as you noticed in the last two that we did, we don't have a coefficient in front of the x squared, but here we have 1. If you have 1, you always factor that out. And if you can't, then that's the next thing we're going to cover with factoring trinomials with the leading coefficient that you cannot factor out. But this one, fortunately, you could factor it out. So the first thing you do is factor out the 3. So the first thing we learned is greatest common factor. Always keep that in mind when you're factoring anything. The first thing in factoring, you look, do we have a greatest common factor? And if we do, take it out first. Okay. So here we took out the 3 in front of all of that, or 3 as the greatest common factor. And what we end up with is x squared, negative 3x divided by 3, it just gives me negative 1x. Negative 18 divided by 3, it just gives me negative 6. Okay. Doesn't finish here, this one though. This one you have to still go further, open 2 set of brackets, put an x in each. And now you're looking for 2 numbers that multiply to give you negative 6 and add to give me negative 1. Even though we don't write negative 1 here, negative x means there's a negative 1 in there. So the 2 numbers that do that for you are definitely negative 3 times 2 will give you negative 6. And when you add negative 3 plus 2 will give you a negative 1. So it would be negative 3 plus 2. And now if you FOIL this and expand it, you'll get this. And then if you multiply the 3 right through after that, you'll get that. Okay. So that's how you do this one. Now let's just move on to the next ones. So here, factoring trinomials is still, but the thing here, we have a leading coefficient right in front of this, the x squared, and we cannot take it out as the greatest common factor. That's the case here and the case here. 4, we could take it out from 12, but we cannot take it out from 9, so we cannot take it out as the greatest common factor. So in this one here, I'm going to show you 2 different methods, okay? The first method is a simple and fast method, but it's a bit tricky. Once you learn it and you practice it, you wouldn't do the other method anymore. But some students like the second method because that's the first thing they learn and they want to stick to it. But a lot of students, when they see this method that I'm going to do first, they realize, wow, that's a lot faster. It saves me a lot of time during tests, and they start using it. So with this method, what do I do? Okay, I do a little bit of cheat. So what I do, I go, what's 6 times 1? So I multiply that 6 into 1 and move it there. So x squared plus 5x. And as I said, the 6 times 1 gives me 6. So I'm just going to write plus 6. Now this and this are not 1. Okay, don't think, oh, I solved this, that's no problems. That's a little cheat that you could do. But what I want you to remember that we have a 6 at the front there that we have to keep in mind for later. Okay, so now let's just know that we have a 6 right there. We're going to keep this in mind. But let's now factor this. And when you're factoring this, you see that right away. That's x plus 3, x plus 2. As I said earlier, with factoring trinomials, you just look for 2 numbers that multiply to the constant and add up to the coefficient of x, and 3 times 2 gives me 6. And when you add 3 and 2 gives you 5. The thing, it doesn't finish here. And that's why I said, keep in mind, you have a 6 there. When you get to this stage, you divide this number by 6, divide this number by 6. And what you end up with x plus 1/2 here, and x plus 1/3 here, because we're reducing the 3 and the 6 gives me 1/2, and the 2 6 will give me 1/3. And when you get to this stage, all you need to do is just push that 2 in front of the x there and push that 3 in front of the x there. So you'll end up with 2x plus 1, the 1 stays where it is, and the 3 in the bottom comes where the x is, and you still have the plus 1 there. So now see, if you multiply 2x times 3x, you'll still get the 6x squared, and the 1 times 1, you get 1. That's how you always test them, because this, when you multiply this by this, you should get this, and when you multiply this by this, you should get that. And then you go 2x times 1 is 2x, and 1 times 3x is 3x. When you add these 2, you get 5x, and therefore you got it right. All right. Now, how about this one here? This one, I'm going to show you a method called decomposition. So just let me write that word down, decomposition, and that's what you see taught in most schools. And decomposition, what you do, you multiply this number and that number. And when you multiply them, you get what multiplies to 36, okay, and adds to the middle number here, which is negative 12. So still what multiplies, instead of this, you multiply the 4 and 9, what multiplies to 36 and still adds to the coefficient of x. These 2 numbers that will do that for you is negative 6 and negative 6, because negative 6 times negative 6 will give me positive 36. And when you add these 2, you get negative 12. So what you do here, you rewrite this equation as 4x squared, but instead of minus 12x, you write minus 6x, these 2 numbers here, okay? The negative 6 and the negative 7, minus 6x minus 6x, and then you still have the plus 9. So decomposition, basically what you do, you change that number to this right here, to 2 numbers. The ones that you got from here, that's negative 6 times negative 6 that we said. Let me just kind of, those numbers are hidden. I just want to make sure that you see them. So it's the negative 6 and the negative 6 here. That you multiply to give me 36 and add to give me a negative 12. So instead of negative 12x, we wrote negative 6x minus 6x, which in turn really adds up to negative 12x. Okay. So decomposition, that's what you do. And once you get there, you break it in the middle. And when after breaking in the middle, take out the greatest common factor from this binomial at the beginning here. So the greatest common factor is 2x, and you get x minus, or you get 2x minus 3. Okay. So again, you're just write it nicer. So you look at this binomial and take out the greatest common factor, which is 2x, and then 2x squared divided by 2x, you'll get 2x, and minus 6x divided by 2x, you'll get minus 3. And you go to this binomial and take out the greatest common factor, and here the greatest common factor is going to be 3, and you'll still get 6x divided by negative 3, you get 2x, and positive 9 divided by negative 3, you'll get negative 3. Now, when you do decomposition, always this and this have to end up being the same. That's what decomposition is. When you do this third step or second step here, this and this end up being the same, which means you could take them out as the greatest common factor. Because if you look at all of this, this is one term right here, and this is one term. Both of them have 2x minus 3, both terms. So if both terms have the same thing, then I could take this and this out as the greatest common factor, and it will end up with inside the other brackets is this 2x and this minus 3 right there. And look at it. This is a perfect square trinomial. So as a matter of fact, you know, there's a shortcut to do it, but I just wanted to show you decomposition. And this will give you 2x minus 3 squared. Okay. So two different methods factoring those kind of trinomials. When you have a leading coefficient, the choice is yours in math. If anybody tells you to have to follow one way, I don't agree with that. You know, whichever way that works for you and you really enjoy, and because it's easy or because it's fast, it's up to you. Go ahead and use it. All right. So now we'll go to the next part of factoring. So hey, now factoring the difference of two squares. I think my personal opinion, this is the easiest factoring you'll ever see. Why? Because simply you just open two set of brackets. You ask yourself, what's the square root of x squared? It's x. So you put an x here and an x there. And then what's the square root of 49? Is 7. Put 7 there and 7 there. And then you make one of them plus and one of them minus. So how do we recognize the difference of squares, or the difference of two squares? Okay, some call it difference of squares, some call it the difference of two squares. Well, the difference of two squares, it tells you that there are two terms. It's a binomial. Binomial means two terms. You only have two terms here. Like here, you have only two terms. Here you have two terms. Here you have two terms, you know. And it's a difference. The difference means you minus. Okay, so this is a plus. If you have x squared plus 9, then you cannot factor that anymore. We don't have any way to factor this unless we use imaginary numbers, and that's a different lesson at a different grade level altogether. But you cannot factor the sum of two squares, but you could factor the sum, but you could factor the difference of two squares. Okay, so that's the trick about it. So as you see here, this is a perfect square, this is a perfect square. When that's the case, then we could factor them as the difference of squares. As I said, one of them is plus, one of them is minus. It doesn't matter. You can make this plus and this minus, or this is minus and this plus. It doesn't matter. The square root of 9x squared is 3x. So you just put 3x here and there. And the square root of 25 is 5. So you put 5 here and 5 there. Isn't this the easiest factoring you've ever seen? Okay. It gets a little bit complicated though. So here you look at this and you say, okay, that's the difference. But the problem, this is not a perfect square. The x squared is a perfect square, but not the 12. And the y to the 4 is a perfect square, but not the 27. Now, can we see if we have a greatest common factor? Because I said always the first thing you need to look for when you're factoring, if you have a greatest common factor. Here, I could see there's a greatest common factor, which is 3. And if you factor out a 3, then you're going to get 4x squared minus 9y to the 4. And at this moment here, you carry the 3 and you recognize this is the difference of two squares because that's a perfect square, that's a perfect square binomial, and then a difference in the middle. So therefore, now you take what's inside the brackets, carrying the 3, and then you take what's inside the brackets and you factor it using the factoring of the difference of two squares. So you square root of 4x squared is 2x, you put 2x here and 2x there, 1 minus 1 plus, and the square root of 9y to the 4 is 3y squared. Oops, I need a bit of a room there. So let me just kind of make the 2 nice and clear then and close the bracket a little bit later. And then, so as I said, the square root of 9y to the 4 is 3y squared. So you write that at the end here and at the end right there. And that's basically the factoring the difference of squares is still here is much nicer like this. Yeah, so I'll go through this one more time. First thing we look out for the greatest common factor is 3. Now I take out the 3, and when I take out the 3 as a greatest common factor, I get that inside the brackets. When I look at this, I realize it's, or recognize this is exactly the difference of two squares. Then I use that method on here as well. So the square root of 4x squared is 2x, so 2x here, 2x there. The square root of 9y to the 4 is 3y squared here and 3y squared here. And then one of them is minus and one of them is plus. One more, and this I'm doing it because lots of people will factor this into x squared minus 9 and x squared plus 9, and they stop right there. If you stop right there, you only get a half a mark. Okay, so this is again, it follows the rule of the difference of two squares because two perfect squares here and there, and that's the difference. The square root of x to the 4 is x squared, so x squared here, x squared there. Square root of 81 is 9, 9 here, 9 there. Now the only thing, this here, this part here is still the difference of the two squares. Okay, so therefore x squared factors into x minus 3 and x plus 3. However, that x squared plus 9, you keep it as because we cannot, remember I said you cannot factor the sum of squares. So therefore, this is as far as you could go. All right, now the next thing I'm going to do, I'm going to show you how to factor by grouping. So factoring by grouping, as you see here, we have not a trinomial, but a polynomial with four terms, sorry. So when that's the case, what we do, we break this in the middle. So we break it right here. And we look for the greatest common factor from here, which is 8x. And that will give me 8x squared divided by 8x will just give me x 16x divided by 8x, just minus 2. See if you multiply this here and there, you get this. Plus, here we'll factor out the greatest common factor from this binomial right here. And it's 3, so then I get x minus 2 as well. Now, since these two are the same, and you have two terms, now when you look at this, you take out x minus 2 as the greatest common factor, and then you collect the 8x plus 3 in one bracket. And that's how you do the factoring by grouping. Yeah, maybe I should write the title right there, by grouping. The same thing we do here, so break it in the middle. And the greatest common factor here will be 3x, and I'm going to get x squared minus 4. And the greatest common factor from here is negative 2. And what I end up getting is x squared minus 4. It's a sign change. You see negative 2 times negative 4 will give you a positive 8. So when you factor out negative 2, the sign will change. That becomes 4. Now we have x squared minus 4 as the greatest common factor. So we put it out as the greatest common factor. And if anybody doesn't understand what that means, if you look at this, we have two terms. Now we have this term right here and this term right there. And both of them have x squared minus 4 in both terms. So that's why I could take that out as the greatest common factor. And I'm left with 3x minus 2 in the other bracket. Okay. Now this one is not like this. It doesn't stop right here because I just realized now x squared minus 4 is the difference of squares, just that. But you know, with the difference of the two squares, this here follows that. So the x squared minus 4 will have to factor into x minus 2. x plus 2 according to factoring the difference of two squares, and then I still have the 3x minus 2 right there. That's how you factor by grouping. But in this one, we ended up doing by grouping, and then we ended up having to factor the difference of two squares right here. So the last one I'm going to do is factoring the difference on sum of cubes. So when you're factoring the difference on sum of cubes, you have to follow rules. So sum of cubes, if you have a cubed plus b cubed, then the factor of that is a plus b. So basically the cube root of a is a, the cube root of b is b. So you write a plus b in brackets. And then in here, you just square this, you go a squared, and then you put a minus and you multiply the a and b, that's what goes there. And then you put a plus and then you square that and you get a b squared. So that's the rule. And it's the same thing with the difference of cubes. So when it's a minus here, then you put a minus here and these two become plus, but you end up with the same thing inside the brackets. So to be able to do this, my advice to you always is to identify what's your a and what's your b. So if this is a cubed, then a would be the cube root of this, which is 2x. And b would be the cube root of this, which will be the cube root of 27 is 3, and the cube root of y cubed is 3y. Now you could start filling in these. Okay, so the first thing, as I said, you write a plus b, so 2x plus 3y. And then in the other brackets, you square a, which is a is 2x, so you square this, and when you square the 2x, you're going to get 4x squared. And then the sign after that is minus. And after that, you multiply a and b, so 2x times 3y just gives you 6xy. Okay. And then you put a plus sign. And then you square the b. See, b is squared, so you square the b. Since I wrote the b right here, I shouldn't even look that back there. So the square of b, square of 3y is going to give you 3 squared is 9, and y squared will just give you y squared. And that's basically how simple it is once you determine what a and b is. Okay. Now, how about the sum of cubes? Again, we should identify our a, and our a and b here will be a is the cube root of this here, and the cube root of x to the 6 will be x squared. So that's the cube root of x to the 6 is x squared. And the cube root of 125 y cubed, the cube root of 125 is 5. And the cube root of y cubed is just y. Now this becomes easy. So all I need to do is just put my a here, which is x squared, and then plus, as it's shown me here. Hold on a second. Let me back up a little bit. Okay, I don't know why I was doing the sum of cubes here. When it's the difference of cubes, fix the signs. That's all I need to do. So here and here. So when it's the difference of cubes, this was the difference. I was under the impression it was the sum, but when it's the difference, then this should be negative and these two are plus plus, as in here. Okay, it doesn't matter what that sign is. It's when it's a difference of cubes, then it's negative plus plus. That's how I remember them. And then if it's the sum of cubes, then it's plus negative plus. So here we should have plus b, which is 5y. Okay. And in the other brackets, it's going to be the square of a. So a, when you square x squared, you're going to get x to the 4. And then we multiply. Hold on a second. I'm doing the sum of cubes. Yeah, we multiply. So it's going to be minus. And then we multiply a and b. So multiply x squared times 5y, we'll just get 5x squared y when we multiply a and b. And then at the end, you're going to have a plus, and it's b squared. And since b is 5, then square 5 is 25, and you square the y, you get y squared. And this is how you do the sum of cubes. So just a mistake that was made there. If it's the difference of if it's the difference of cubes, make sure your signs are negative plus plus, and if it's the sum of cubes, then your signs should be plus negative plus here. Okay, and then you just figure out your a and b, and it becomes easy after that. And that's it. Now you know how to factor polynomials like a pro, whether it's using common factors, grouping, or special formulas. You've got the tools to break down any expression with confidence. If you found this video helpful, don't forget to like, subscribe, and hit that notification bell so you never miss a new math lesson. Thanks for watching Math with Sammy. Keep practicing and I'll see you in the next one.